Hi class, in this video we're going to be looking at how to determine the function from a graph for an nth degree polynomial. So basically what we want to do for these is we just want to identify what our intercepts are, and you're going to be given some other point to help find your stretch. Okay, and of course we're just going to solve these just using factored form because it's going to make our lives easier. So I'm going to make note of my x-intercept. Oh, hello, didn't mean to do that. I'm going to make note of my x-intercept. So I've got an x-intercept here at -4, -3, 1.75, and 4. And of course, I want to be careful and note if there's any bounces going on or any flattening happening, and I've got none of that. So this is going to be pretty straightforward. I know I have some vertical stretch, so I'm just going to leave that alone for a second. And I'm going to write this as x plus 4, x plus 3, x minus 1.75, and then x minus 4. Okay, and then I'm going to look and see what's another point that I can use to help out. And then you're going to see here, I just made a note to say the y-intercept is 21. So that means that 0, 21 is on this curve. So because it's on this curve, I can plug in 0 and 21 to my x's and y's respectively and solve for a. So I can say 21 then is going to equal a. 0 plus 4 is 4, 0 plus 3 is 3, 0 minus 1.75 is going to be 1.75 or 9 over 4. Did I do that right? 8 over 4. Oh, no, I want 7 over 4. There we go. And then 0 minus 4 is -4. And by the way, that should be a -7 over 4. So let's just do this piecemeal here. So so 4 times 3 is 12. 12 times 4 is going to give me -48. So I'm going to have -48 times -7 over 4. And then 48 and 4, I can just reduce that twice. So I'm going to get 24 and 2 and 12 and 1, 12 and 7. Oh, geez, these are big numbers. I'm just going to go 21 divided by -48. Well, here, I could do that one. I can do 12 times 7. And the negatives will disappear is equal to a. Let me see if I can do that quickly. That'll be 70 and 14, 21 over 84. 21 over 84 is equal to a. And by the way, I'm expecting a positive because I can see this is going to be opening up. And I'm expecting an even degree. So 1, 2, 3, 4 x's. I get an even degree polynomial. And 21 over 4, or 21 over 84, I think is 1/4 for my a value, which makes sense. And by the way, because just as a little note for the students in my class, like I'm going to be constructing these questions, your a values should look pretty nice. Like you're talking about like integers or really basic fractions, fourths, eighths, fifths, thirds. You shouldn't get like 17 over 13.24. Like as soon as you're getting stuff like that, maybe go back to the drawing board and see if you missed something. And that's the vibe there. So the only other way that these questions get a little bit hairier is if, for instance, you see a bounce going on or a flattening. So again, I'm going to make note and say, okay, I must have an x-intercept, so y is equal to a, and then I'm going to say, all right, x-intercept at 1, x plus 1. I have an x-intercept at 2, x minus 2, and then I say, hey, it bounces there, must be squared. Some of you might say, how do I know it's not a fourth? I can be pretty confident here because I don't see a flattening, so I'm just going to say it's just going to be squared. If I did see a flattening around there, then I might put a fourth. It's not going to be an expectation, though, that you're going to definitively be able to recognize what higher power it is. Just note that as soon as you see a flattening, go up to the next interval and just use that. And then I'll solve for a. Is there another point here? There is. It's 1, 1. So I can say, hey, 1 is equal to a. 1 plus 1 is 2. 1 minus 2 is -1 squared, or a is equal to 1 over 2, because 2 times 1, 2 divided by 2, a is equal to 1/2. So I will write this as a, and I don't know if I took time to write the final answer, but I'll take time right now, x minus 2 squared. And you would want to write that somewhere, and the answer is no, you do not have to expand into standard form. That's fine right there. We're focusing on getting the function from the graph. Okay, something like that would be a flattening there. So for that one specifically, I'd want to see x plus 3 cubed, because you can clearly see right there you've got a flattening, whereas with the other one it's just x plus 1, and then you just have your a value and y. And again, I would use the fact that this is 0 and 20 1/4, -20 1/4 to solve. But just in passing, I would be expecting a negative a value popping out, because I can see it's an even degree function opening down. And I think that, yeah, that's what do we have here? Dividing polynomials. That's the next video that we'll do. So that's it for this one, and I'll see you guys in the next video.